Okay, so this is our first part of curve fitting with linear models, and we're going to develop our own linear model using our graphing calculators. But today we're just going to learn a few things before we do that. All right. So eventually we're going to work on making a scatter plot using our graphing calculator, and then using those linear models to make predictions, which is really why we make a linear model. Okay. To get us started today, I want you to take a look at this picture and estimate how many cheese balls are on the shelf here. We'll pause here. Okay, so if you remember, at the very beginning of our linear unit, we did a Lego activity. We all came up with our own model using the data points that we had. And here was a compilation of all of our estimates and our linear models. Notice they're very similar, but there is some differences, especially as you get further to the right on the graph, further down the x-axis. So once again, why do we make linear models? We really do that to make predictions. Researchers are often interested in how two measurements are related. And this study is called regression, the statistical study of relationships between variables. And this is a pretty important study for many science fields. Okay, so one of the ways we can start to determine relationships is by making a scatter plot, and then we can see what the correlation is. And a correlation is the strength and the direction of the relationship between the two variables. And a positive correlation, you'll see a trend of the data points trending upwards. And the stronger the correlation, the more tightly grouped the dots will be. So you'll notice on the left there that this first graph here, they're a little bit more spread out. So this is a positive correlation. Because they're a little bit more spread out, though, it's not quite as strong. This is a very strong one. And this last one doesn't happen a whole lot in the real world. Notice it's almost perfectly straight. So that doesn't happen quite as often. You would probably more see something like this, or even the first one in the real world. Okay. Now, by the same token, we have the same type of thing here. We have a negative correlation. The one on the left there is not quite as strong, but it's trending down, as you can see. And you can see that with all of these here. And once again, stronger correlation, more tightly grouped points. Okay, and then sometimes you'll just graph some stuff and you'll notice that there is not a correlation between these two variables. So you might say an example of this would be if you were to plot the weather and the days of the week. So maybe you think, oh, well, on Tuesdays, I've always noticed that it's always snowing on Tuesdays. Well, maybe there's a couple of times where that might work out, but we know that that is actually not. Just because it's Tuesday doesn't mean it's going to snow. So there's no correlation there. So when you graph a couple of things here, sometimes you might get no pattern at all, and that should be indicated in your graph. And we want to make sure we have enough data points to see that correlation. Like if we have a small sample size, then it's going to be something that we might not be able to draw conclusions from. Okay, so I tried to figure out a way to think about something called the correlation coefficient. And this is just a number that indicates the strength of the relationship between two variables. And our graphing calculator can do this for us. So we use, for correlation coefficient, we use the letter R. This is an abbreviation for it. And really what we want is the correlation coefficient is somewhere between 0 and 1. It'll be a decimal. We usually round it to 2 decimal places, the nearest hundredth. Or it might be, if it's a negative correlation, between -1 and 0. So the stronger the relationship, the closer it is to 1 or -1 if it's negative, okay? So I tried to think of how is a good way to think about this. Well, I thought of Hollywood relationships, which are pretty challenging and they don't really last that long. So if we look at this one on the left, what do we think the correlation coefficient would be? And then if we look at this relationship on the right, what do we think the correlation coefficient would be, and how strong the relationship is? So we'll pause here and talk about this a little bit. Okay, so correlation coefficient. Again, this is our R value. So this is R. And when we use our graphing calculator, that will be given to us and will determine how strong a relationship is. Now, the stronger the relationship, the more tightly grouped the dots will be, the data points will be. So you'll notice here, this first graph, this is a negative correlation because it's trending. Notice it's trending down, so it's negative. And then this negative 0.95, that's very, very close to 1. And you'll notice those dots are very tightly grouped. So this is a very strong correlation coefficient. We would definitely like that kind of data. That's good data. Same thing with here. This is a positive version of that, tightly grouped, but it's trending up. So we know that that's a very strong correlation, and you can see here 0.95. This one right here it does have a trend towards a positive version there. However, it's kind of scattered, and then you can see that the estimate here is about 0.6 for a correlation coefficient. That is not real strong, and this would be the same thing for the negative version. And then this is really in the middle here. There's no correlation there. So you can see the correlation coefficient is 0. To me, that looks kind of like the invincibility star that you get in Super Mario Brothers. If you were to outline it, kind of looks like that. But anyways, this is what your correlation coefficient indicates. It's the strength of that relationship. How strong is that relationship? And again, we will be able to find this using our graphing calculators. Okay, so what do we want to determine is a strong correlation coefficient? We really want to only use data if it is a strong correlation. For our purposes, if the R value is greater than or equal to 0.75 or negative 0.75, we want to use that data. We would be considered strong. Okay. Moderate and weak, we generally want to stay away from. So if it's below 0.75, we kind of generally will stay away from that data. However, sometimes we might consider a moderate correlation. And this would be somewhere in between 0.5 and 0.74, okay? So somewhere in that what we would say is moderate, and then anything less than 0.5, this is considered very weak, and we would definitely not use that data. There might be some instances where we would consider using a moderate, but generally for our purposes, we want to just anything greater than or equal to 0.75 is what we want to use, okay? So when we get our data, look to see if that's above 0.75. If it is, then we would say that's strong data to use, and we would use that linear model to make our predictions because it's good data. So as I said, in our Lego activity, we had the app there was able to draw our line of best fit, and we're going to do this in a different way, and that is to use our graphing calculators, because we don't have a linear model app necessarily, but we do have our graphing calculators that can do this for us. Okay. So, first thing that I want you to do, next time we're going to talk about how this is done, but this time what I need you to do is to go in and find your MCA calculator. Mine's here at the top, and make sure that you can get in here and everything is working, because this is the calculator you will have to use. So if you haven't used this before, make sure that you can access this and you don't have any problems. Let's say you try to go to your app and it doesn't work real well. there's a couple other options that you can do, and I want to show you that here. So if I go to Schoology and I go to either 4th period or 7th period, you'll notice here at near the top it says distance learning resources. In here, in this folder, there's a link to Graphing Calculator, okay? So you can come in here. If that wasn't working, you can either click this TI-84 link, okay? And if that hopefully will bring that up. If that still doesn't work, then there's another option that you can do. You can open up Safari and then copy and paste this URL into the address. So hopefully one of those two things work. Your job is to make sure that that's working before we come to class next time, because we will be using this exclusively for our lesson and also on your assignment. Okay, so that's your job for tonight. All right, that's it for today. See you later. Have a good one.